In this one, they want us to find the inverse of the matrix. So there is an algorithm that you can use to find the inverse of a matrix. So I want to show you how to do it. Here's what you do. By the way, you're never going to be asked to find the inverse of anything but a square matrix. So it'll be a 2 by 2, a 3 by 3, a 4 by 4, nothing like a 5 by 2. But usually what you do is this. Form a single matrix, but separate the given matrix by a vertical bar, and to the right of the vertical bar put the identity matrix of appropriate size. All right. And what you're supposed to do is transform the left-hand side into the identity, and whatever this ends up being is the inverse of the original matrix. Okay? So I'm just going to try to transform the left-hand side into the identity using row operations. So I guess what I would do is divide the first equation, or the first row, by 4. And really, you could use Gauss-Jordan elimination, same trick we used before. Now, first one by -3, add it to the second one. So that'd be negative, I'm going to use a calculator for this, -9/4 plus 7. -3/4 plus 0. I guess I don't need a calculator for that, and that just stays a 1. Now let's divide this by 19/4. Okay, one more step. I want to change this into a 0. So it looks like I want to multiply the second row by -3/4 and add it to the first row. So it looks like our inverse is this. That would be A inverse is equal to that 2 by 2 matrix. And so how do you double check? If you wanted to double check, just multiply by the original matrix and make sure you get the identity. Okay, so I might just do it in one direction. I might even just check one entry just to make sure that I'm on the right track. So if I do row times column, the first element ought to be a 1. Let's see. 28/19 minus 9/19. That is 19/19. Looks like we do get a 1. This should be a 0. Let's see. -12/19 plus 12/19. It is a 0. I bet you it checks out. All right. I just wanted to say one other thing that's kind of related to the last few sections that we've been doing. Just some basic properties of inverses. You can show that if you find the inverse of a product of matrices, assuming they're both square matrices, well, it's kind of tempting to say, well, maybe that's the inverse of A times the inverse of B. It's almost true, but you have to remember to switch around the order. And that's also true, by the way, when you take the transpose of a product. It's the transpose of the first matrix times the transpose of the second matrix, but you have to switch the order. And this kind of came up in, I think, some of the problems in the last section. What is the transpose of a matrix? It is just the matrix that you get when you switch around the rows and the columns. All right. So let me just give you an example. If I wanted the transpose of this matrix, well, the first row is 1, 2. Just change that into the first column. The second row is 3, 4. Change that into the second column. So you can show that this is true as long as these products are defined. And this is also true in general. But remember, you can only find the inverse of a square matrix, so you kind of have to assume that A and B are square matrices in the first case. So I just wanted to kind of throw that at you if that makes it easier to do some of the problems.